Hello everyone and welcome to today's session. In this session, we will be discussing about remote sensing platforms and sensors. So, till now, we have seen that what is remote sensing and that how remote sensing is done. Basically, as we have discussed earlier, remote sensing is a process or remote sensing is the science and art of acquiring information about any particular object, phenomena, or earth surface features without coming into contact with the feature. And the remote sensing is basically done with the cameras. So, to understand platforms, we need to understand this concept first. If we are capturing the image of an area or object with the camera without being in touch with that feature or object, then we must need a platform which is looking at the object or the phenomena from a faraway distance. And here in this session, we will see or look into these types of platforms. So let's start. First of all, it is very necessary to understand that what is platform. Basically, platform is a surface at which any kind of sensor or any kind of remote sensing camera is mounted or placed. Platform refer to the structure or vehicle on which remote sensing instruments are mounted. These can be aeroplanes, cranes, drones, kites, pigeons, hot air balloons, etc. Remote sensing platforms are of three types. First, ground-based platforms. Second, airborne platforms. And third, spaceborne platforms. Now we will look into these three kinds of platforms one by one. First of all, let's look into ground-based platform. Basically, ground-based platform, as the term describes itself, these type of platforms are connected with the ground. Ground-based platform is a wide variety of platforms that are used in remote sensing. Some basic examples of ground-based platforms are handheld devices, tripods, towers, and cranes. As in the figure, you can see there is a crane upon which the camera is mounted. And in the second figure, you can see a tripod at which the camera is mounted, which is performing the remote sensing process. Basically, ground-based platforms are used to acquire information about small areas. Like if we need to capture information about any grass, a particular area, a particular field, then we will use ground-based platforms. Now let's move on to second type of platform, which is airborne platform. This term also explains itself. Airborne platforms are basically non-ground based platforms, or basically those platforms which travel in the air medium. The first aerial image was acquired with a hot air balloon in 1858 and 1859, as we have discussed in the history of remote sensing. The first aerial image of Paris city was acquired by Gaspard Felix Duncan, aka Nadir, by his hot air balloon. As we all know that hot air balloon is a platform which travels in the air medium. So camera which is mounted on the platforms or on the objects which travel in the air are known as airborne platforms. Some examples of airborne platforms are aeroplanes, helicopters, drones, kites, pigeons, and as well as hot air balloons. As we all know that nowadays balloons, kites, and pigeons are an outdated type of air-based platforms. The recent advancement of the airborne platforms can be seen in aeroplanes and drones. So now, after discussing airborne platforms, now let's move on to spaceborne platforms. Satellites are the most suitable example of space-based platforms, as spaceborne describe itself that those platforms which are based on space. So satellites are those devices which are stationed at a particular orbit above the Earth's surface. They can be at various types, various heights according to their usage. So, the first remote sensing satellite was launched in 1960 for the meteorological purposes, and hence it started the trend of spaceborne platforms. Nowadays, there are thousands and hundreds of satellites that are mounted outside the Earth atmosphere in their orbits, and they are classified by their orbits. So, these three are the types of platforms. This figure shows all the examples categorized under ground-based platforms, airborne platforms, and space-based platforms. Under ground-based platforms, there are tripods, cranes, etc. Under airborne platforms, there is uh, drones, helicopters, aircrafts. Under space-borne platforms, there are satellite, space shuttles, etc. This figure also shows that the examples of different types of platforms, and this image as well as shows that what kind of imagery is acquired with the all the three types of platforms. Now we will move on to types of satellite. Basically, there are many criterias to divide types of satellites. In this session, we will be looking into types of satellites based on the orbits. So, there are two most important types of satellites based on their orbits. First is geostationary satellites, and second is polar orbiting satellites, or as we can say, sun-synchronous satellites. First of all, we will look into geostationary satellites. Geostationary satellites describes itself as geostationary. Geo means earth, stationary means stable. So, geostationary satellites are basically those satellites which seem to be stationed at a particular point while looking from a point in the Earth's surface. But as you all know that this is not true. Satellites always keeps on orbiting the Earth's surface. So it is not possible that any particular satellite is stable or is stationed at a particular point. But now the question is, why then it is known as geostationary satellites? So, moving on to this, first of all, it is very important to know that a geostationary satellite is also a Earth orbiting satellite. It is not stationary as we have discussed. It is placed at an orbit of approximately 35,800 kilometers directly over the equator. The maximum altitude at which a geostationary satellite can be placed is 36,000 kilometers, and the geostationary satellites move in the same direction as the Earth, and it takes approximately same time to rotate on its orbit for one time as the Earth requires to rotate once on its axis. Like Earth rotates on its axis in 24 hours, and geostationary satellite also takes 24 hours approximately to take one full round of its orbit. That is why, while looking at a point from the Earth's surface, geostationary satellite seems to be stable at a particular point because it is moving with approximately same speed as us. The term so at one particular time, a particular or a single geostationary satellite can approximately cover 40% area of the Earth's surface. So we at least require 3 satellites working simultaneously to cover the entire Earth. So, and the main work of geostationary satellites is weather based or for communication. This is a figure of geostationary satellite. In this figure, a particular satellite is orbiting around the Earth and is capturing the data at the same time. And it is, if you will see closely, the orbit is directly overhead the equator. So it is a speciality of geostationary satellites that they are orbited exactly above the equator. This is also a figure showing the orbit of the geostationary satellite. Now, after discussing geostationary satellites, we will move on to sun-synchronous satellites. This term also, as always, explains itself. Sun synchronous, meaning synchronized with the sun. These orbit allow a satellite to pass over a section of the Earth at the same time of the day. To discuss, we we know that we have to know that these satellites are synchronized with the speed of the sun. Orbit of these satellite is between around 700 to 800 kilometers, whereas we have seen the orbit of the geostationary satellite is around 36,000 kilometers. So sun synchronous satellites are at a very much lower altitude than that of geostationary satellites. And this type of satellites need a constant amount of sunlight to capture the Earth's surface information. Some examples of sun synchronous satellites are Landsat and QuickBird. The basic purpose or the basic use of sun synchronous satellite is for military purpose. This is an example showing sun synchronous satellites. This figure shows two satellites that are orbiting around the Earth in their respective orbits. One other kind of satellite based on orbit is polar orbiting satellites. This polar orbiting satellites has derived its name due to its orbiting around the poles. These type of satellites orbit from North Pole to South Pole and then again from South Pole to the North Pole in next phase. This figure shows the movement of polar orbiting satellites. As you can see, the satellites are moving on their orbits from one pole to second pole, and beneath it the Earth is rotating in its direction. So now this is all for today's session. In next session we will discuss about resolution. So thank you so much for this. See you in next session.